Hello everyone and welcome to the first video of our Python and Matplotlib course. Today we're just going to be dealing with the basics of graphing. We're going to go over the software that we're going to be using for the rest of the course, the IDE, and how we're going to implement Matplotlib and use it for whatever it is that we're planning to do. In order to get started, I'm not going to take too long. We're just going to load up any type of web browser that you can use. Whatever is comfortable, really, it does not matter, as the IDE that we're going to be using is a website itself, so it's all good whatever you choose to use in the end. I'm just going to load up Firefox right here, and whether it be Google Chrome, whatever it is, you just want to search up Collaboratory. That is the software that we're going to be using. There you go, that's the exact spelling if you want to get it right. And this first link right here that says welcome to Collaboratory. Collaboratory is what you're looking for. It's a project by Google and you can make Python scripts with it. I found it very useful. It might prompt you with this for just previous projects. If you have any, just close out of that. You won't need it. Most of you will most likely end up on the screen right here that just says welcome to Collaboratory. You will have a bunch of options here just like any other web page or IDE. From here, all you want to do is hit File at the top and then New Notebook. You can close this previous tab if you'd like, and it'll open up this development environment for you right here. Perfect. The way this works is that you have different shells in which you'll type in code. You can keep everything in one shell, or you can separate them individually. For example, I can write all of my code in this shell as so, or I can move on to another one and type something in there. Nonetheless, no matter what, we don't want it to be like this. We're not just going to be inputting random letters, of course, so return back to your first shell. Keep it blank for now. You can even delete it and open up a new one. By pressing code up here, it'll open up its own cell block, and from there we can start from scratch. In order to work with shells, once you type something in, if you want to run it, you're going to have to press Shift Enter, and if you want to move on to the next line, you just press Enter and that's it. Make sure when you're writing long programs here and you split it into multiple cells, if the first part of the program is required for the second part, you're going to have to run the first part first, as it's necessary in order for it to function. So to ignore all those issues, we're just going to put everything in one cell block. We can get started right here. The first thing we're going to do is import Matplotlib. What we're going to be using is a specific part called pyplot for the rest of this course. It's extremely common. And the way that we're going to import this is by just typing in import matplotlib.pyplot. And we don't want to reference it as this every single time we have to. So we're just going to type in as plt, and we can use plt whenever necessary. This is extremely common and very common practice when it comes to using pyplot. Moving on to the next line. The first thing we're going to do is plot a very simple line graph. The way that we can do this is by setting a value for x, or a number of values for x, and then a number of values for y. After that, you can plot it with just a very simple pyplot line. It's not going to take much work at all. These are the very basics of Matplotlib. Let's go ahead and make our x-axis. I'm just going to call this x, and have it equal to 1, 2, 3, 4, 5, 6, 7. There you go. So a very simple list. If we make another one called y, we're just going to have this for 20, 30, 40, just random values I'm putting in here. Make sure it's exactly 7. It has to be matching with the x, as there cannot be any extra values of y that do not correspond to an x value. After that, all you're going to do is plot this as so. You're going to type plt.plot, and then you're going to give it an x term, which is going to be x, and then a y term, which is going to be y. After that, at the end, you're going to have to type in plt.show with 2 brackets, and this was all you're going to need to plot in this very simple line graph. If I were to run this, you'll see that it runs, and we have a very interesting graph over here. It covers everything we need to. We did not need to specify the limitations of the x or y axis. It'll do that by default based on the numbers that you give. For example, the x-axis goes from 1 to 7, and the y-axis goes from 0 to 100, which is fair for the numbers that we have. This looks a little funky. I didn't mean to specify any values that are important. These can vary, and you can use whatever you want for this. It won't matter too much. The next part of this is actually titling the graphs and giving it some value. We're going to want an X label, a Y label, and also a title at the top. You're going to be using this a lot, so make sure you have this down. In order to do this, it's very simple. Right before we have our show, we're just going to type in a few more terms. So the first one is the title. In order to do this, you can just type plt.title, and you can title this whatever you want. This graph I'm going to have represent muffins sold over a week for maybe a small business, so I'm just going to call it that, muffins sold over the week. That's perfect. Next, if you want your X title, you're going to have to type that in as plt.xlabel, and then in the exact same fashion, you're going to call this whatever, day of the week this would be, so it goes from 1 to 7, and then our random values for Y will be referenced with Y label, similar to X label, very similar fashion, and this time we're just going to specify it as number of muffins sold. Perfect. Now if you were to run this, you don't need to add it in any way. You'll see that it pops up on our screen in the designated locations that we were expecting. Small error over here, if I can see, number of muffins sold, right? There you go. Just rerun that. Just a little capitalization mistake, nothing to worry about. This is what we're looking at right here. Looks perfect. Moving on from this, the next thing that we're going to add in are colors and line styles to our graph. In order to add a specific color to the line graph, you can specify it right here in plot. After the Y term, just type in color equals, and then inside of quotes, you can type in whatever color you want to put in. These aren't going to be too exact, and you can't type in something like light red and expect it to work, or very specific colors, but just something like red will give you a graph of red. You can actually try that just typing in light red, see what it gives you. Doesn't work, right? So doesn't need very specific terms. Red is something that matches the agreement. After that, you can also add in a specific line style. The way that works is that you just specify it as another term. So after this color equals red, you can add in line style equals, and then whatever you want the line style to be. There is a variety of options, and you can find different ones online. You won't be able to guess a lot of them, but the default one is just this dash that we have right here. So if we were to run that, you'll see that it looks the same. But if we were to add in 2 dashes, you will see that now it has been dotted a bit, so it looks a little different. Great. The next thing I'm going to add in is another line graph on top of this chart. You want both of them to be adding in. Maybe the second one will be muffins sold over the next week, or by a different user. In order to add in another set of data, we're just going to be keeping more values. So for example, we have X and Y, we're going to make an X2 and Y2. Except in this example, we won't need to make a second X because we're going to have the same X values. It's just going to be different Y values. So after this, I'm just going to make another variable called Y2 and give it a set of 7 values. These are all going to be random once again. I'm not trying to make this specific in any way. Anything works here. That's 5. We just need 2 more, and I'll put 24. There we go. In order to plot our second graph, we're just going to put it as another plt.plotline. This time we're going to have to specify the X and Y again. So it's going to be X as normal, and then Y2 this time, and we can continue adding in our specifications. So our color for this one can be blue, and our line style is going to be a singular dash. Now if we were to run this, you'll see that our second graph has been added in as expected, and it looks a lot different from our regular one, but it follows the same terms for where it lands on the X and the Y and is within all the values. So if I were to make this 99, something like 200, you'll see that this will branch off in to a whole new region. Now it goes to 200, so if we want to keep all the values within the same range, we can make this 100 as well, and that's the cap. Perfect. Another thing that we can look at is marker. If you add a marker term in here, for example, marker equals dot, you can see that what this looks like is a little bit of a dot at every vertex point. So right here, right here, right here, right here, and right here, there are multiple options for the markers as well. and that's something that we can take a look at. I've opened up two new web pages right here, one for markers and one for lines, as you can see. And we can take a look at both of these and see what we want to throw in. So line styles, we have dash dash, dash dot, this colon. Okay, we can try some of those, and we can also try some of these. So for the marker, maybe I want to add in this pentagon. That looks pretty cool. So instead of just this dot, which is kind of lame, I'm going to put in P, run that, and you'll see that if we zoom in, it's a pentagon. It's not too big, but you can distinguish it. Maybe something that's a little bit more distinguishable, we can put this filled in X, so capital X, and you'll see that that gets filled in, and you can tell that it's an X pretty clearly. As for line styles, let's see where that is. Dash 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 dot. All right, we'll try the dash dot. Actually, we'll try it for the second one because that's just default. There you go. This looks pretty cool. Dash dot. And is there anything else that's interesting? A dotted line, we can try that. So that's just a colon. You can see that it's a perfect dotted line. Looks pretty clean. And you can keep experimenting with these. There's a lot of options out there and a lot of other terms that you can add to this. So in terms of just the color, line style, and marker, you can find them online. Colors, I'm sure you can as well. I found another web page that should have a list of colors. As you can see, we have blue, brown, pink, gray, whatever. And you can go ahead and try those out as well. So if I want to make the second one pink, that would work just fine, or even olive. Pink is pretty hard to see, but olive should be fine. You can see this one pretty clearly. The next thing we're going to look at is different plot styles in Matplotlib. If you want to check the different plot styles, at the start, you can just type in print plt.style.available, and it will print out all the available styles right before or after the graph. Let's see. There you go. You got this list. So you got classic, dark background, fast, 538, which is the most common from what I've seen, grayscale, Seaborn. These are all pretty nice. I want to try out fast because I haven't seen that before. So if you want to set a specific plot style, right in your first sequence or wherever really, you can just type in plt.style.use, two brackets, and then the name of the plot style you want. So let's say you want fast. You can go ahead and enter that. And there's not too much of a difference for this one, but let's say I try something like dark background. You'll see a pretty clear difference. Dark backgrounds. There you go. So now it's black and white instead of white and black, or it's just the inverse of what we had before. And if we were to try something like default, it will just revert back to what we had before, a little bit bigger. And maybe, let's see, what else is nice here? Seaborn dark. That's a pretty cool one. Seaborn dark. There you go. This one looks pretty nice. So there's a lot of options for that available for you. The next thing is also the grid. So let's say you actually want a grid inside of this. You can add that in pretty easily as well. I'm just going to revert this back to dark background because I like that one a lot. Also going to make this color, let's see, what's another nice color? Cyan. There you go. And at the end here, if you want to add in a grid, all you're going to type in is plt.grid and then true. If you set this to false, it'll turn right back off. So if we were to run this, you'll see that there is now a grid for our graph. I don't like it too much though, so I'm just going to go ahead and turn that off. But this would be necessary for a lot of different graphs, as I'd imagine. Another thing that you can add to your graph that's especially necessary in this example is a legend that says what each of these lines represent. So in order to do that, right before the grid, I'm going to type in that term or that line. It's going to be plt.legend, and then in brackets, I'm going to put two different values. So first, square brackets are going to be necessary, and then two different terms or quotes that we're going to use to represent the data. So since we put red first for the plotting, we're going to have to refer to that one first. So that's one's just going to be sales 1, and then a comma after your first quote, and it's going to be sales 2 for the second plotting. And if you were to just run that, you can see that as we'd expect, sales 1 is the red and sales 2 is the blue. It keeps the line formatting and everything of that nature the same, so you won't have to deal with that. It works on a lot of this stuff for you, so you'll just have to get the main idea across for most of these things, and you'll be alright. In terms of content, that's all I have for today. I just want to give a brief introduction to this software and library as a whole. I hope you got something out of this, just making simple line graphs. Nothing to this really, just the main point is how to actually plot them. When you're plotting them, you want to include all your terms, so the X and the Y, and then everything that follows. So your color, your line style, your marker, and there's a bunch of other stuff that we're going to be exploring that's unique to line graphs, pie graphs, bar graphs, histograms, everything that you could possibly imagine. Another thing is just looking at the legend, how the labeling works. Take note of all this as it will come up again, especially when you're making your own graphs. All these things are, of course, going to be important, and you don't want to miss out on anything that's vital. With that being said, that's all I have for you today. I'll see you in the next lesson when we talk about bar graphs and more functions that are used commonly in Matplotlib. Hello everyone, and welcome back to another Matplotlib tutorial. Today, we're going to be creating bar graphs in Python and exploring more factors that go into graphs of all kinds. For example, a lot of the attributes that we deal with today will also apply to line graphs, also scatter plots, pie graphs, and histograms, which we're going to be dealing with in the future. So without further ado, I'm just going to go ahead and get started. Whatever IDE you use, it does not really matter. I do prefer Collaboratory because you have all the libraries pre-installed and there's nothing that you really have to deal with externally. Also, everything saves online, so I think this is a pretty useful software. But if you want to use just the regular idle shell, Atom, something like that, it really does not matter as long as you have Matplotlib installed onto your device. With that being said, I've went ahead and created a new file under Collaboratory and I'm ready to get started. The first thing that we're going to do is import Matplotlib. We do that the same way we did last time, so we're going to import matplotlib.pyplot as plt, and we're going to continuously reference that, and today we're also going to be using numpy as np, just to make a very simple number array when it comes time to do so. With that being said, the first thing I'm going to create is our x titles before our actual x axes. So the graph that we're going to be creating today, or the data that we're basing this graph off of, is votes for your favorite superhero. We're going to have two different sets of data. One of them is going to be for a specific survey size, and the other one for another demographic. With that being said, I'm just going to make a couple of titles, or ticks, that go for every single superhero name that we're going to feature in our graph. I'm going to make a variable called xTitles, have that equal to a list that goes over every superhero name that we're going to be dealing with. The first of them is going to be Superman, and you guys can customize this to whatever you want. It really does not matter. It's not super important. I'm just trying to go over the concepts and make it a little bit interesting. There we go. We got 3 so far. We're going to need, we got 4 so far. We're going to need 3 more. So once again, anything works here. I think I'm going to throw in the Flash, Wolverine, and actually, that should be good. We can just leave it at 6. Make it a bit simpler. After that, what I'm going to do is make the y-axis. So this is going to go from different values that correspond to each of these different names that we have here. So for example, how many votes for Superman we have, how many votes for Green Lantern we have, how many votes for Batman, how many votes for Hulk, the Flash, and then Wolverine. So first of all, we have Superman, and that's going to be 15 votes. Then moving on to the second one, maybe we have 17. Then we got 14, 12, 13, and once again, these numbers don't matter too much. I just want to keep it within the same range, maybe 20, and then that's 6, isn't it? Perfect. And now we can move on to our x-axes. The next thing we're going to deal with are our x values. Instead of having to make an array from scratch and write in every value, we're just going to utilize NumPy to create this array for us. How are we going to do that? Well, we're going to make our variable x and have it equal to np.range, make sure that's spelled right, and then the length of our x titles. What this does is that it will make an ordered series of numbers that go for the length of x titles. So if you're a little confused as to how that looks, you can go ahead and print x, and you can see it'll just go from 0 to 5, and they'll all be evenly spaced out. So if you just give it 1 second, that will print out. In the meantime, or actually there you go, it's right there, 0, 1, 2, 3, 4, 5 in an array. Perfect. Now that we have our x and our y axis, we can get to plotting this. Instead of doing plt.plot, which is what we did last time, in order to specify and make this a bar graph, we're going to have to type in plt.bar. And within the brackets, we're going to specify the same argument, so our x and then our y, same as last time. Now if you were to run this, you'll see that it works just fine. And one more thing that we do have to include just for proper form, plt.show, it will get rid of that top line right there. There you go. Now you have our bar graph as written or as shown with the specified values that we gave it. The next thing we're going to do is add another set of data onto this bar graph. Let's say we interviewed another demographic with the same question, and we want to plot their data as well for every single individual in the list. In order to do this, we're going to do it the same way we made another line graph in the previous lesson. We're just going to make another set of y values, and then have it equal to another bar graph, or we're going to make another bar graph with those values. In order to do that, we're just going to make another variable or another array called y2, and our x is going to stay the same. It's going to still go from 0 to 5, and we're going to give this a couple of values that are similar to this one. Let's say we interviewed a similar size of demographics, so any set of random numbers between, I'd say 10 to 20. I'm going to make this one something like that. Once again, it's going to be very simple, and make sure you keep it to exactly 6. Perfect. Now, in order to plot this, we're going to do it the same way we did last time. We're just going to add in another plt.bar. Last time it was plt.plot. Once again, we're doing plt.bar to specify that it is in fact a bar graph, and we're going to have in our new variables, x and y2. Now, if we were to run this, you'll see that they are plotted, except there is a huge issue here. The problem is that our graphs are overlapping. The larger scales of the bar graph for the second one are overlapping the first one, and vice versa. Obviously, we don't want this. We don't want our bar graphs to just be on top of each other in this huge cluttered mess that's one-dimensional, so you can't even see what's going on. Instead, you want to space these out a bit. The way that we're going to deal with this is with width. And the way that this width variable is going to work is that we're going to set it to a certain float value or a certain integer. Then we're going to put it inside of this bar graph and set the bars to a certain width and maybe move over one of them as well. Before we get straight into that, I also just want to add in all the ticks or all the titles for each of these bars. We don't want it 0 through 5. We want these to represent all the superheroes that we've made right here. In order to do that, you're just going to make a new line under all of this, and we're just going to write in plt.xticks, and within that, for every value of x, it's going to go under x titles. So these are corresponding values, meaning that for 0, it will go to Superman, for 1, it'll go to Green Lantern, for 3, it will go to Batman, etc., etc. And if you were to run this now, you'll see that all the names come up as shown in the proper order that we put them in. It is a little hard to see because they are overlapping, so maybe we can make one of these names a bit shorter. Instead of Green Lantern, I'm just going to put GL, and hopefully our users will understand what that says, but that looks good to me. You can actually see it perfectly now. The only one that's a bit annoying here is this Flash and Wolverine, so I'm just going to write Flash instead of the Flash. There we go. Now we have a nice set of data to work with. Along with that, I'm also going to add in the title and then the X title, the Y title, etc. I'm going to put that on the same few lines, or the same spacing. We did this last time as well. I'm just going to give a good name for my graph here. Votes for the best superhero. And then our X label is going to be the superhero name at hand. And then PLT Y label, or Y axis, is going to be titled number of votes. Perfect. I might also throw in a legend, just like last time, where the first set of data, and make sure you include your square brackets here, the first set of data that we have that's plotted, which is the X and the Y, that would be the first set of data, so I'm just going to name that data A, and then data B. Maybe we can even make this demographic A, and demographic B. Now if you were to run this, you'll see that you have our legend and also all the titles, so it looks a bit cleaner. We just have to deal with our main issue here, which is the width and the spacing of these bar graphs. In order to do that, the first thing that we're going to do is make a variable called width. At the very start of this document, I'm just going to make a float value called width, and it's going to be equal to 0.2. Now, 0.2, if you set these bars equal to that, or the width equal to that, it will make them quite thin. You can experiment with this value and see which one suits your graph best and what actually looks the most optimal, but I'm going to keep it to 0.2 for now. I think it's a good amount of spacing, and the way that we're actually going to add this into our graph is that within both of these plt.bar initialization statements, we're just going to add in width equals width. It's the same way that we had the color equals blue last time and everything else that went into that line graph. Width is one of the parameters that we have to specify here. You could also make this width equals 0.2, but I'm just going to keep referencing this width variable. So width equals width goes into both of them. Another thing that I want to add in is that right here, I want to make it x plus width. So for every variable, it's going to move over 0.2. Therefore, it's not going to be overlapping anymore. They're both going to be pretty thin. And the second set of data, is going to be moved over 0.2 units. Another thing I want to add is some colors. So I'm going to go ahead and throw that in. Color equals purple for the first set of data. And then the one that's moved to the right, I'm going to make it color equals pink. Perfect. Now if we were to run this, you'll see that not only has our data been spread out just a bit, but you can also see the legend, which has been placed nicely, and also the fact that our graphs are a lot thinner. In case you want to make this a bit different, you want to try out another width, you can make width equals 0.4 and see how that looks. Let's see. Yeah, this actually looks a lot cleaner to me. So there is very little spacing within the graphs. They're all right beside each other, and you can compare all the values side by side. And this, I think, is a great representation of bar graphs and how you approach them with Matplotlib. If you want to experiment with a third set of data, you can do that as well. You'll just have to make a new set of y values or a new y array, and this one is going to have similar values to it. Of course, we want all of these to be within the same range so our graph doesn't look too odd, and we're going to need a 6 value, so I'll just throw in 12. There you go. And now we're going to have to plot this again, so set plt.bar x plus width, make this x plus 2 width because that's to move over double. And then, let's see. Yep, you also want your width to be a bit smaller, so make this 0.2 so that they all fit in. And maybe I'll make this going from red to pink to purple. There you go. Now if you were to run this and check it out, let's see if they're actually going in just fine. 2 times width, that's not going in. Alright, let's see. Make it 2, yeah. Just some incorrect formatting here, width times 2. That'll work better. And now you can see that all of our graphs have been put one by one, side by side. I think this would even work for 0.3 as our width, so let's try that out. Yep, I mean it's a little tight, but maybe 0.25 instead. There you go. So you can see that votes for best superhero has been put in. You have your 3 sets of data. You can also experiment with the colors, make that look a bit better, maybe blue, then green. Actually, let's make it purple, blue, green. Yeah, that'll be good. Purple, then blue, then green. This is just for the sake of formatting and making it look nice. Make sure your syntax is correct everywhere. Well, actually, that doesn't look very nice at all, but I'm just going to leave it at that. Obviously, you can mess with the colors. That's not too important. The syntax is what really matters. You can always experiment with these type of things that are not too important. With that being said, that's really all I have for you today. I hope you learned something new, not only about Matplotlib properties, but bar graphs, which was the focus of today. And if you want to carry this into your own learning, you could do it in multiple ways, maybe implementing your own data. Then you could try it out for both line graphs and bar graphs. But that's all I have for you, and I hope you learned something new. Thanks for watching, and I'll see you in the next lesson. Hello everyone, and welcome back to another video. Today, we're going to be using Matplotlib again in order to work with pie charts. We've already dealt with bar graphs and line graphs. Now we're going to move on to this realm, and it's actually a lot easier to work with and a lot more fun, in my opinion, as there's a ton of properties that go into it, and a lot of customization. I'm not saying that there isn't a lot of customization for bar graphs and line graphs, but you'll see today that we'll have a long list of things that go under our plt.plot. With that being said, I'm just going to get straight into it. A lot of these properties, once again, that we use today will come up again, not for all types of graphs, but for pie charts for sure, especially if you're going to make another one in the future. This will help your customization with the colors, the explosion of how it comes out. You're going to see exactly what that means in a minute. So the first thing I'm going to do is go ahead and import Matplotlib on a new collaboratory file. You can use any IDE as long as you have Matplotlib, matplotlib.pyplot. Make sure you have that down exactly as it should be. And then that's the only library that we're going to be using today, no NumPy. I'm just going to keep it very simple. First thing I'm going to do is just set our style, so plt.style.use. And I'm going to be using 538 for today, which is a very common style. You can use whatever style you want. Once again, if you want to know how to look at them, you can refer back to the first lesson, and it'll give you a long list of all the different styles that there are for all types of graphs in Python. Next thing we're going to do is create our labels. So before we get into that, actually, I think I'm going to make our slices first and then move on to our labels. That sounds pretty good. But the way that slices work is that since we're not dealing with an actual graph, such as a bar graph or a line graph anymore, we don't have an X and a Y axes. We only have slices and the values of them. Therefore, we're just going to make an array called slices and have it set to a series of values that represent every slice that goes into the pie chart. So let's go ahead and make that. We have an array called slices set to a certain amount of values. I'm going to make our pie chart have exactly 5 values and have it total up to 100. So 20, 40, there you go, it's 60, 70 after that, then 15 and 15. There you go. It's all evenly split, so we can work with it in percentages afterwards. Now what I'm going to do is make our labels. So the labels are what's going to be surrounding every single slice, and it's going to correspond to every value here one by one. So the first label is going to go for 20, and the last one is going to go for 15. Make sure you have exactly 5. And the way that this pie chart is going to work is that I'm going to make it like a pizza. So every single name is going to correspond to a certain topping or exclusive topping that's on that slice only. So the first one will be cheese, that's 20%. Then we have sardines, which is 40%, not very common, but that's how we're going to have it for today. Green olives, black olives, and then pepperoni. There we go. Now moving on from that, I'm just going to go ahead and make this graph itself. If you type in plt.py this time, instead of plt.plot or plt.bar, it will work with a pie chart instead. So if you write in plt.py, and within your brackets, instead of typing in your X and your Y, you're just going to write in slices. And after that, plt.show will show your entire pie chart. That's all you're going to need, and that's the only value that's required for a pie chart to actually show. So if you go ahead and run this, you can check that out in real time. Just wait for it to save. There you go. You have all 5 slices, but they haven't been titled yet, and that's something we'll add in just a second. The next thing we're going to add in is a shadow. So we don't want this to just look like a piece of bland colors or just a few bland colors. We can have it so that there's a shadow that goes around every single slice. It won't be too defined, or it won't be so extremely visible, but it will be something that makes it look better. And the way that we add that in is just as a term under plt.py, do a comma, then shadow equals true. Now if you were to run this, you'll see that we have our shadow. Give it a sec. There you go. Perfect. You can see exactly what's going on here. There's a slight shadow around the edge. Makes it look a little bit more three-dimensional and active. The next thing we're going to throw in is our labels. So this is another term that you're going to add in. Instead of xticks, what we did last time, you're just going to add in something called labels equals labels, which is our array. And now if you were to run that, it will go around the edges of the pie chart and show what everything means. Perfect. Another thing that you can throw in is the title, which we've already dealt with. It's the exact same way. We're just going to be typing in plt.title, the name of the bar graph. So I'm going to call this slices of a large pizza. And of course, if we run this, you guys know what this will look like, but it's just at the top. There you go. The next thing that we can add in is percentages on every single slice of this pie chart. if you just put in a comma here, then put in auto PCT for percentage equals, and then this exact character is what I'm going to put down. You're going to have to put down as well. It's going to be percentage 1.1 F percentage. This doesn't actually mean anything logically, but it will just show the percentages when you throw it on. It's not something you actually have to fully understand. Hold on, let me just make sure I got this right. It's got to be 2 percentage signs, right? There you go. Now if you run this, it'll work just fine. This is not something that logically makes sense. At least I can't actually explain why it's 1.1 F percent, but that is what works, and you will be dealing with this in a number of different ways when you start working with pie charts more often. The percentages on here, it looks like it's just colliding a little bit, so I'm going to make one of my slices, this slice, the 10 slice, a bit bigger than this one, a bit smaller, so maybe that will support it a bit better. Yeah, just a little bit. Make it 12 and 18. I think that'll be perfect. There you go. Not even actually, but I think this is fine. We can even try 14 and 16. I just want to even out perfectly. Yeah, that's good. So you have your percentage on every single slice. The next thing that you can do is add in angles. So how much you want this chart over here to angle, or how much you want it to turn. Right now would be 0, but if we add another term into this pie chart and said start angle equals 90, it would turn 90 degrees. There you go. The next thing that we can deal with would be the colors. So if you want to add in colors to your pie chart, it's very simple. You're just going to make an array called colors and then have it equal to a set of colors, and then set your pie chart equal to those colors, so it'll designate to every single item there is in your pie chart. So for an example, let's make an array called colors and have it equal to 5 different colors. Red for cheese, green for sardines, yellow for green olives, blue for black olives, and then purple for pepperoni. Now if we add another term in here and just say colors equals colors, so the colors property is equal to the colors array in our pie chart, you'll see that all those designated colors come into play right here, one after the other. I'm going to put my start angle at 0, just so that we can take a look at that. Exactly how we had it before. So sardines is green, our cheese is red, our pepperoni is purple, our black olives are blue, and our green olives are yellow. These colors don't actually mean anything, and they don't truly represent what's going on here, but it's enough to show how it works. The next thing that we can throw in is an explosion. So how much you want one of these to pop out. For example, let's say you want to show that someone took the cheese slice out. The way that you can do that is with the explode property. The way that we're going to do this is the same way that we did it for colors. So we're going to make a property, an array called explode, and have it equal to how much you want every single one of these designated items to explode from the pie chart. So first you got your cheese. I don't want that to explode. I don't want the sardines to explode. I don't want the green olives to explode, but I want the black olives to explode. So here I'm going to put 0.1, and that will take out the slice just a little bit. The more you increase the number, the more it'll be taken out. Then the pepperoni, I'm going to set that to 0, and right here at the end of all these terms, I'm just going to write explode equals explode. Now if I were to run this, you'll see that the black olives has been taken out just a little bit. You might have to zoom in to see it. There's a bit of a shadow there. And if you were to make this number a bit bigger, like 0.5, you would be able to see that very clearly. There you go. Black olives is way out of the graph. And obviously, if you were to make it a number greater than 1, I think it would be a bit too much of an explosion. You want to keep it pretty reasonable. So 0.5 is good, just to show it very clearly. The last property I'm going to show is wedge prop. So it'll be the edge color for everything going around here. You can do this pretty easily as well. You don't need an additional array. At the end of this, you're just going to type wedge props equals, and then with 2 curly brackets, within this you're going to write edge color, then a colon, black. So black will be surrounding every single one of these every single slice of these pie charts, or sorry, every single slice of this pie chart. There you go. Now if you were to run this, you'll see that, like I mentioned, black is surrounding every single slice of this pie chart. Perfect. That's all we're going to look at for today. I've tried to put this into a very compact sequence of everything that I planned to go over. There's nothing too crazy that we looked at. It was just the basics of pie charts and then some features that go along with it. One thing that I did take notice of is that I don't really like these colors, and I don't think anyone does. If you want to get some nicer looking colors, you can search up the exact color code of what you're looking for, or get like a color code generator for the exact color that you want and then search through it. And then what you can do is that you can actually input it here under the array. So for purple instead, maybe you have a certain color value that you want to have. You can use that instead of just the default purple, which is very vibrant, and it doesn't look great. It doesn't look very good. And especially if you're dealing with something like this, where a pizza actually does have designated colors for certain toppings, you would want it to look precise and somewhat exact. With that being said, that's all I have for you today. I hope you learned something new about pie charts in Python, and I'll see you in the next lesson where we talk about scatter plots. Hello everyone, and welcome back to another video. Today we're going to be dealing with scatter plots in Python and Matplotlib. These are actually quite simple to work around, and they're actually really cool, and there's a ton of other features you can add onto them, and we're going to take a look at that right now. To begin with, I have a new Python file open on Collaboratory. I'm going to go ahead and import pyplot as plt, and that's the only library we're going to use for today. After that, I'm just going to make an X array and a Y array, and that's the only set of data we're going to be working with. We're not going to be making multiple graphs this time, just one will do just fine. So for the X, it's just going to be in a random range from 1 to 10, and since it is a scatter plot, I do want to make a ton of points, so I'm just going to throw in a bunch of different values here. So let's say you have 1, 4, 3, 2, 6, 5, 7, 8, 9, 4, 3, 2, 5, 6, etc. I'm just gonna make this super long because it really does not matter. There we go. Now I'm gonna make our set of Y values and make sure it is exactly the same number of values that you have in it. The length should be the exact same. It shouldn't differ because then you're gonna have some errors and an unknown value. So here I've made sure that it's the same in length. You can count it for yourself if you'd like to, or you could just run it and check if there's any errors. Great. Now, in order to plot this as a scatter plot, we're going to have to write in plt.scatter, and then your x and your y. There you go. Then plt.show at the end. And now you can run this and check how it looks. Give it just a sec to connect to Collaboratory, and you can see right here, we have our scatter plot. So it is obviously very random points, and this will be the basis of what we're making today. So after this, I'm just going to make my titles real quick. So I'm going to make my title, just going to call this data A, and then my x-axis, right? So the title isn't too important for this one because I didn't really have anything in mind. I'm just trying to create a decent looking graph, so I want to include this always, just some sets of titles because it makes it look a lot cleaner. I'm also just going to change the style that we have here, so plt.style.use, I'll make this Seaborn. There we go, we can check that out. I just think this one looks a lot better with the grid, and it's overall just much cleaner in comparison to the default layout. The next thing I want to add to this scatter plot are a set of random values that represent the colors. So for colors, I'm just going to make an array. It's going to be called colors. Should be good. And this is just going to be equal to a bunch of values. And these values will represent different things on the color spectrum, and you'll see how that looks in a second. I'm also just going to rename this variable to C, just so it's in line with everything else and I can count it properly, because we're going to have a designated color for every single point on this graph. So I'm going to go from 1, 2, 3, 4, then make it very random, as long as it's between 1 and 10. 9, 2, 10. Actually, I don't even want to keep those, just so I can keep it even with both of the other arrays that we have here. There we go. Now, if you were to add this in right here, if I were to write C equals C, C stands for color, you'll see that you have a new random set of colors. Some of them are very hard to see. Therefore, we're going to work on the color map now. So right after this, if I write CMap for color map, there's a set of color maps that you can use for different scatter plots. One very common one that I really like is reds. If you run that, all your plots will be red. Some are still very hard to see, so you might want to change some of these smaller values from 1 instead, maybe use like 6. Now you'll see that that first point is at least a little distinguishable, and follow that along for the rest. So I'm going to go ahead and edit that real quick, then I'll come right back. All I'm doing is making these values a little larger so that you can actually see them properly. So I made a quick edit here. All I added in was a 1 in front of every single value here, and that made some of them a lot darker, and you can see everything a lot more clearer now. Therefore, I'm going to move on. I encourage that you do the same thing. You go ahead and adjust your values. You can also change the style that's used in order to make it a little bit more visible if that's necessary. The next thing I'm going to do is something else that helps with visibility, and that's the edge color around every single point. So if we just add a term here called edge color or another parameter and set it equal to black in parentheses, or sorry, in quotes, my bad, you'll now see there is a black outline around every single dot. For some of them, it's not as visible until you zoom in and you actually take a look at it, but it is there for everything. Another thing you can add in is the line width of every edge. So if you type in line width, have it equal to 1, that will make it a little bit thicker. There you go. Now you can see everything very clearly. Another thing that you can change is the size of every single plot or every single point. If you just keep a variable called s or a parameter called s and just set it equal to, we can start with 5 and check how that looks. You'll see, oh, that made it a lot smaller actually. So if you want to make it 25, I think that would make it bigger than what it was before. Or no, that's around the same size. We can try 100 then. That would make it huge. There you go. And maybe this looks better because it's just a little bit more visible. The last thing I'm going to add in here is a color bar that's on the right. It's just going to show all the colors on the graph that we have and what they represent, if they even represent anything to begin with. In order to do this, we're going to do it the same way that we make certain things in Matplotlib, which is assigning a variable to it, then plotting that variable afterward. And I'm just going to make this variable called cbar for color bar and have it equal to plt.colorbar. There you go. And after that, we're going to set the name of the color bar. So we're going to do cbar.set underscore label and then have it equal to the label that we want. So I'm just going to call this darkness. That should be good because we don't actually have anything to it. Now we're going to have a color bar called darkness. Goes from 11 to 19, which is all the values that we have in here, 11 being the lowest, of course, and 19 being the highest, and it shows a scale of it. Obviously, this could be used for more practical purposes, like if you had a scatter plot that actually represented something useful, or something that might come up in the real world, or a real life set of data. Obviously, you could use this color bar to actually show what these colors mean, if they mean anything at all, if you want to add that into your application. Excellent. With that being said, we've covered everything there is to know about scatter plots in brief detail. There's obviously a lot more that we could go into detail about, but this is the basics and you can take this a long way. With that being said, I'll see you in the next lesson. Thanks for sticking around. Hello everyone and welcome back to another video. Today we're going to be dealing with stack plots in Python. Stack plots in Matplotlib can be used to show how data grows over time. For example, a good example of how to use a stack plot would be for the number of points a basketball team acquires over a game. This can be based on the number of minutes as each interval, and also every single player can be split up into their own rank or their own set of data. This can be done quite easily, and it can also be super useful for certain data types. That's why I'd like to go over it and show exactly how we use it. In order to start, I'm going to import Matplotlib. So go ahead and load up Collaboratory and import Matplotlib onto your new file in your new cell. Now I'm just going to set my style for this plot to be, sorry about that, 538, which is a very standard one that you're going to see come up more often. 538. I just think it looks very clean and it's super popular. Now we're going to make something that's similar to our x and our y. So our x in this case is going to be the hour, and the graph that we're going to be making is eggs found over the duration of a search. So it's like an Easter egg hunt, and you might have a couple of players, how many eggs they found at every single hour of the search. So our x-axis is going to be the hour, and this game is going to run for 6 hours, let's say, and whoever has the most at the end is of course the winner. We're going to have 3 different contestants here, and they have a certain set of data for how much they found. So contestant 1 has an array, and let's say in the first hour they had 1 egg, in the second hour they had 2, then it progressively climbs until the 6th hour they have 6. So they found 1 egg every hour. Now for our second contestant, we're going to make this 1 for the first hour, 2 for the second hour, then maybe even 4 for the third hour. Then they found 2 more in the 4th hour, so now they have 6. Then they found another 1, and then they couldn't find another 1 in the 6th hour, so they finished with 7. Now you have one last contestant who maybe didn't do as well as the other 2, so contestant 3, and maybe they started out with 1 for 3 rounds actually, then they found 4 eggs, then they found another, then they found 2 more. Actually, yeah, we'll make this contestant perform the best. Just for the sake of the scatter plot, you'll be able to see how this looks when somebody starts out pretty poorly, or the data starts out really small, then gets to the biggest over time. Now we can actually graph the stack plot. In order to do that, we're just going to be typing in plt.stackplot, and we're going to have to include the x, which is the hour, and then every single other set of data that's going to be plotted onto this. We don't actually have to specify a y, because that's what our contestant variables or arrays do. So contestant 1 is our first set of data, contestant 2 is our second set, and contestant 3 is our third set. And if we now just plt.show, you will be able to see this pretty clearly, how this would look in its own default colors. So just give that a second to initialize, and you can now take a look at how that would be. So this orange set of data would be contestant 3, this red set would be contestant 2, and contestant 1 has a very steady climb. That is the least performing or the lowest performing contestant we have here. That's why they finish at the bottom. But they all start at around the same spot. You can also see how many eggs they've got together as a whole by the end, which is about 21. And if you add up all these values, you'll notice that that's true. Perfect. The next thing we're going to add in is labels for each of these players. In order to do that, we're just going to make a variable called labels and have it equal to each of these contestants. So our first label is going to be contestant 1 for, of course, contestant 1. And you might already be able to guess what our other 2 are going to be. There we go. And now in order to actually initialize these variables, we're going to throw that under the stack plot. So labels equals labels. Labels is recognized as the parameter. And after that, we can also put this in our legend. So we're going to make a new line here, plt.legend, and it's actually going to be able to store it already just based on the labels. So if you were to run this, it would show that. But the issue is we don't really want the legend to be up here in the top right. So if we want to move it to the top left, that is very doable as well. This is not something we've looked at yet, but in order to change the location of the legend, you can just type in LOC for location equals then where you want it to be. So upper left, let's go ahead and see that. You can see that now it's been moved to a nice location in the upper left. It's not touching the y-axis, so it looks pretty good. And obviously it's not in the way of the data anymore, so that's perfect. With that being said, that's really all there is to stack plots. There's a lot of other parameters that you can throw in here, but I just wanted to keep it very simple just to give you a brief introduction to how these work and how you might expect to use them in the future. Also just the use case. So I think the best use case was actually a basketball game and the players. You can go ahead and try that for yourself if you'd like to. You can even get data online and then graph that. With that being said, that's all I have for you today. Thanks for watching, and I'll see you in the next lesson. Hello everyone, and welcome back to another Matplotlib video. Today, we're going to be dealing with 3D plots in Matplotlib. 3D plots are actually very straightforward, and there's no additional software or libraries you need to create them. In order to work with 3D plots, you're only going to need pyplot, so it's actually not that bad, and it's not too hard to set it up either. With that being said, we can just go ahead and get started on that. Also, one more thing is that we're going to be dealing with another parameter today, which we haven't talked about, called alpha. I just want to throw it in because it's also applicable to the graphs we made in the past and all the graphs you're going to make in the future. Let's go ahead and get started for our 3D graph. So the first thing we're going to do, of course, is import matplotlib.pyplot as plt. Make sure you spell that right. There you go. And we're also going to import a library called NumPy as MP. We've used NumPy in the past. I can't remember exactly what lesson it was, but it was to generate a number array, which is also what we're going to be using it for today. Space out, and now the first thing we're going to make is our X and our Y. These are both going to be NumPy arrays because they're just going to have a bunch of values in it, so I don't want to write them out by hand. In order to do that, it's very simple. We're just going to have X equal to np.random.randint. So what that does is that it'll generate random numbers with these specifications. So it should be between 0 and 100. That's what I want my values to be between. And then how many values we want to create in this array. So 600 is what I'm going to keep it at. We're just going to have a bunch of points on this graph. So once again, it's going to generate 600 numbers between 0 and 100. Now, of course, we want this for the y as well because it has to correspond to every value. Therefore, we're just going to be typing in y equals np.random.randint, 0, 100, then the number of values, which is 600. Perfect. And since it's a 3D plot, we're also going to be needing a z-axis, or a number of z values, because it has to be on that plane as well. Now it's no longer in 2 dimensions, it's in 3. So our z is going to be equal to the same thing. Random.randint, of course it's going to need exactly 600 values as well. So every value of the x corresponds to every value of the y, which corresponds to every value of the z. Now, the next thing we're going to do is actually set this plot to be a 3D plot. In order to do that, at the top here, I'm just going to make a variable called axes and set it equal to plt.axis and then the projection. So the projection is 3D. If you want it to be 2D, you could just write 2D in there, but of course we're dealing with 3D plots today. And also, your graph is 2D by default, so there's not much you need to do for that. Now we have our axes actually set to 3D. This is exactly how you write it out, and we're ready to plot our graph. So we're making a scatter plot for today, and with that being said, we're just going to reference axes once again. So our 3D projection variable or 3D projection graph, axes.scatter. So the same way we did plt.scatter, we're now doing axes.scatter. It's still under Matplotlib, of course, and we're going to be taking the first few values, which is the x and the y, and then the z right after. Now, that's all we're going to use for today, or no, sorry, not for today, just for now. And if we go ahead and try that out, you can see what it looks like. We're going to be adding more onto this, of course, but just give Matplotlib a second to connect and collaboratory, and you'll be able to see this. There you go. So you just got a bunch of points between 0 and 100 on each axis, and you have a pretty nicely drawn 3D graph right here, I'd like to think. It gets cut off a little at the bottom, but that's not too important. You get the general idea, and that's what's important. So with that being said, there's a couple of edits you can make here. First of all would be the size of each of these points. Since we have 600, you might want it to be a bit smaller, so I'm just going to set the size equal to 5. There you go. Now, what's the issue? Oh, no property size, right, so you want to make this x equals 5 instead. That will run just fine. It accepts s, but not size, so s equals 5, and you can see each of these have become a little bit smaller. Now the next thing you want to do is colors. So the same way we did the scatter plot with the colors last time, we're going to be making these colors different as well. So the way we can do that is make a variable called c, and then that's going to be for colors, and have this equal to the same type of array, and it's going to go from 0 to 10 this time. And we're also going to be generating 600 of these, which correspond to all of our x and our y and our z values, or every single point. And now we're going to initialize that right here. So c equals c, c for color, which is the parameter, and c on this side being for the array. And if we go ahead and run that, you'll see a variety of colors that are on this graph. One more thing we can do is add in an alpha parameter. So this is what I mentioned at the start. If you throw an alpha, it's just how much of it you can really see, so it'll be the transparency. So the lower you make the alpha, the more transparent it is. So if you make alpha 0.1, you'll see that it is hardly visible, but if you make it a little bit higher at 0.3, I think that's a perfect visibility, so you can kind of see it, how much it has, I guess you could say, dissolved into the graph that we have here. It's not super visible anymore. Like if you made it 10 or something, it would be extremely visible, or actually it doesn't even accept that value. It has to be between 0 and 1. So 1 being the highest, I believe that's the default. Yeah, so it's just all in your face. Instead, we can just make this 0.3, and that looks a lot cleaner. With that being said, that's all we have for today in terms of scatter plots in 3D or in R3. We're going to work with line graphs in the next lesson, so we're going to be using a function to demonstrate that. It's done in a similar fashion, but it's still pretty interesting. And we can also look at titling these graphs and also different nature of these 3D graphs that we might not have mentioned today. With that being said, I'll see you in that lesson. Thanks for watching, and thanks for sticking around. Hello everyone, and welcome back to another Matplotlib video. Today, we're going to be dealing with 3D plots once again. Except, instead of a scatter plot, we're going to be dealing with different kinds of functions today. In order to work with this, it's going to be in a similar fashion, but instead of axes.scatter, which is what we did last time, we're going to do axes.plot, then supply it with all the parameters it needs, including the XYZ and everything else that we're going to deal with. Let's go ahead and get started on that. First thing I'm going to do is import my Matplotlib under a new collaboratory file. And I'm going to also import NumPy, which is going to come up. So this time we're going to be using the arrange function. And we're just going to get straight into that actually. So let's make our array x. And this is going to be np.arrange 0 through 50. What this will do is make an array of numbers from 0 to 49. It would be 0 through 50 if we did 51. But it takes the exception of the very last number inside of the array, and it'll all be evenly spaced out. So 0, space 1, space 2. You can take a look at it just by printing it out. Just give it a sec to connect. And any second now, you'll be able to take a look. There you go. So from 0 through 49. Now you're also going to make your y for the exact same thing. Y equals np.arrange 0 through 50. You're going to need the exact same number of values. And then we're also going to have our z. So the z this time, we're just going to set it equal to different things that'll show our functions in real time. So z can be x plus y. That would be a very simple linear function. And we can go ahead and plot that as well. So the first thing we're going to do is deal with the projection. At the start here, we're just going to make a variable axis again, equal to plt.axis projection equals 3D. And at the bottom, we're just going to go ahead and plot that. So axes.plot, then our x, y, and z are of course necessary. And if we do plt.show, we can go ahead and take a look at this. So there you go. You have your very simple linear function. Goes from 0 to whatever this is at the top with the values we've given. And if you want to go ahead and try something else, you can. Multiplied, it will look more curved. There you go. If you did to the exponent, it will look like super wavy and start out flat. There you are. And dividing it, I think it'll go into very small numbers, so might look a little exact here, but maybe not what you were expecting. What else is there? You can obviously use trigonometry in this as well. Just make sure you reference NP at the start. So NP sine x times NP sine y. This would give you a super wacky graph. I'm pretty sure it'll just be all over the place, going front and back. Yeah, so kind of like a sound wave. There you go. I think we'll keep it like this for now, just to experiment. I don't really like how thin this is, so I'm going to add in the line width, which is something that we've dealt with in the past. We've changed the line width before. I'm going to make it equal to 3. I think that's a reasonable amount. Let's take a look. Yep, that looks good. What I'm going to do now is add in our titles, which is something I mentioned in the last lesson that we do. So we can do that in a very simple fashion. Axes is what we're going to have to reference because we've used that throughout. Axes.setTitle. Figure 1 parabolic function, or I'm just going to go and call that functions. There you go. Let me just check if title itself works here, or if it's going to need, yeah, it's going to need set underscore title in there. So make sure that's exact. There you are, functions. Just going to name that function because there's only one on here. Then next you can add in your x label in the same way. So axes.set underscore x label. I'm just going to call this x values. Then you're also going to do the same thing for the y. y values, and don't forget the z values, which we are now dealing with. Z label, right? And that's going to be equal to z values. Hold on, there you go. Perfect. And of course, there's nothing else we're going to need to do for this. If we run it, we can now take a look. As you can see, it's a little cut off over here. If you're using a software other than Collaboratory, like your own independent IDE, I think you'll be able to check around this actually, like you'll be able to move it around. So that's pretty cool. I don't think it'll be cut off for you, but with Collaboratory, there are limits to it and how much they actually show you. So there is a bit of a cutoff, but it is in fact saying Z values. You can take a quick peek at that. With that being said, that's all we have for today. We just kind of looked at very simple measures that you can take for drawing lines in Python of different sorts. You can go ahead and experiment this with this in a lot of ways. You can make a lot of different cool functions if you're into that. But this is a very simple one, just a very easy 3D graph of this linear function. With that being said, that's all I have for you today. Thanks for sticking around, and in the next lesson, we're going to be looking into more of the perspective of 3D plots. Hello everyone, and welcome back to another video. Today, we're going to be dealing with plots in Python once again. Continuing off the series for 3D plots, we're going to be talking about surface plots and also mesh grids in Python. These are a lot more complicated to analyze and work with in comparison to your typical line graph or scatter plot. These type of graphs, when plotted, look like a certain surface, and that's why they're called surface plots. They're just a lot cooler and a lot more fun to mess around with. I think surface plots are amazing. They're a great tool that you can work with. In just vanilla Matplotlib, there's nothing additional you need for them, and they look super cool when you try out different color maps, which I encourage you to do at the end of this lesson. The first thing that we're going to talk about is how surface plots work. But before we get into that, let's talk about functions themselves. In the last lesson, we dealt with something that was like z equals x times y. So what does this actually look like? Let's say you have a NumPy array of 6 values for x. It might be 5, 10, 15, 20, 25, and 30, so it increases by 5. Then your y, you also have a set of values. So maybe it's 1, 2, 3, 4, 5, 6. Of course, it's going to be the same number of values. Your z will be the product of x times y. So 5 times 1 is your first z value is 5. Then you have 20. Then you have 45. Then you have, it would be 20 times 4, wouldn't it? So 80. 25 times 5, 125. 30 times 6, 180. There you go. Now you get this cool looking exponential function that's increasing in a curve. And we saw this in the last lesson. It was just a very simple line, but it still did look pretty cool when you plot it in 3D. So, with that being said, how would a surface plot work? Well, the entire premise of it is that every single value is touched by another at least once. So you go from 5 times 1, 5 times 2, 5 times 3, 5 times 4, etc. And once you're done that cycle, you go to 10 times 1, 10 times 2, 10 times 3, etc., etc. And when you include so many points in here, such a large array, you'll get a surface-like structure just because there's that many values. Then you can add it into a mesh grid, which is a NumPy function that's available to you. Hopefully this isn't too confusing. The math behind it is quite complicated and there's a lot to look into. This was just a very brief explanation of how they work, and there's not a lot that I can really cover here because there's just a lot that goes on inside of these mesh grids. You'll see what they actually look like and how complicated they are when we actually get to graphing them. With that being said, let's get started on this. The first thing we're going to do is, of course, import Matplotlib. Now what we're going to do is also import NumPy as MP as usual, and we're going to make our axes projection 3D, just like the last two lessons. There you go. And now we're going to make our x values and our y values. So our x is going to be a NumPy array that goes from -2 to 2, and then we're also going to include a step, which is 0.01. So it'll cover all the values from -2 to 2 in a step of 0.01, so it'll go from -2 to -1.99, I believe it would be, then -1.98. We can take a look at it right here, but it would go from all those values. So you'll have like hundreds of them, I believe. Too many sessions. What's going on here? I think I have too much running, but I'll deal with that in a second. But that's just how it would be. You can take a look at it as how much the number is actually going to change. It's just going to be this, and then these are our limits. There you go. So you're going to do the exact same thing for the y. NumPy range, and then it's also going to go from -2 to 2 with a step of 0.01. Now we make our mesh grid. So we're going to make a variable called mesh x and also a variable called mesh y, and have them both equal to this mesh grid right here. So np.meshgrid, and then x and our y, which are our natural values. And we're going to have our z equal to x, mesh x, minus mesh y. So now you have so many values being taken place, and your z is just equal to all of them. A simple calculation, even one as simple as this, is going to look super sick. So if you just do axes.plot underscore surface, which is necessary for surface plots, you can't just do axes.plot, then all of your values, so mesh x, mesh y, and also z. I'm going to change that name to mesh z actually, just so it keeps the same fashion. Mesh z is equal to that. And if you were to just run this plt.show first, of course, you can now see how this would look. So give me just a second to manage that. I'll be right back. You can run it on your own and see how it looks. The issue was that I had too many collaboratory files open. I went ahead and terminated some, and I've also gone ahead and run this so you can see exactly what it looks like. It's this sheet actually is what it is, and it's just so many values being taken place that you can view all of them in this surface. So if we want to get really cool with this, there's a ton of other surface grids that you can make that just look amazing actually. So one of them that I was looking at earlier, if you did np.cos mesh x times np.cos mesh y, and now you were to plot all that, of course, you'll see that you have this really cool looking graph right here. So it's like, I don't even know how to describe this really, but since we used our step as 0.01, it's so clearly defined. And if you're using another software, I think I already mentioned this, but you might be able to move around with this graph. But with Collaboratory, you're only able to see this view. That's perfectly fine though. With that being said, that's all we have today for surface plots and mesh grids. In the next lesson, we're going to be looking at how you can actually have this predefined to move around. So changing the elevation and changing the perspective. With that being said, I'll see you guys in the next lesson. Thanks for sticking around. Hello everyone, and welcome back to another Python in 3D video. This one is going to be very straightforward. There's not a lot to talk about here. It's just going to be perspective of maps in 3D. So the way that this is done is with two different factors called azimuth and elevation. Azimuth is more of the angle that you're looking at, and then elevation is where exactly on the plane you're trying to look at the graph. So let's say you have this plot right here, which is cos x times cos y, and you want to look at it from the top. Well, if you were in another IDE, you'd actually be able to explore around and drag it. Though there is a lot going on, it might crash your computer. You might get to take a quick look at it, and therefore you would be able to see the azimuth and evaluation at certain points. But since we don't have that, you can just experiment with different values. It's not too bad. Right under this plot surface statement, I'm just going to be writing an axes.view_init. So that will be where you're viewing it, the viewpoint or the perspective, and you're going to have a variable called asim, which is our first parameter. Set it equal to 8, and then your elevation, which is going to be equal to 70. So we can take a look at both of these, how this looks for a graph. This is how it is right now, and right now we are seeing it from the top. So it is having a bit of problems rendering, but you can see it not in like full force right now, but that is how it is. You kind of have this graph that you're looking at it from the top. If you change the elevation to maybe 90, you can see more of it from the very top. And if you were to make it something like 180, you can see where you're looking at it. It's kind of from the other side. So if you were to turn over completely, it won't actually match it with you. So you're going to have to change the azimuth to do that. But I'm going to keep it at asim 8 and elevation 70. I also just want to briefly talk about some cool color maps because I know I mentioned that. I'm just going to add in some Cool ones here, just so you can take note of them. One of them is cool warm. You can see. So this goes from blue to red. I think this one might actually be my favorite. There's a couple of other really cool ones though. There's also plasma. Then there's rainbow. You can see that. There is rainbow's a really cool one. There's also cube helix. And there is Virtus. I'm not sure if I'm pronouncing that right, but you can take a look at it. And also Inferno, which I'm going to close off on. Perfect. That's all we have for today. I just wanted to make this very, very simple video about perspective in R3 and how you can look at these graphs at certain angles by default. Now, once again, if you're using another IDE, you'll be able to check it out on your own with perspective, zooming in, all that stuff, depending on what you're using. But just by default, if you want to set it to a certain perspective, you can do it with azimuth and elevation. That being said, that's all I have for you today. Thank you, and I'll see you later. Thank you all for sticking around till the end of this course. We've unfortunately come to an end, but in the short amount of time we spent together, we managed to discuss and practice 2D plots, 3D plots, and a multitude of attributes and parameters that go into both of these. I hope you all learned something new and found something very interesting throughout the entirety of this course at least once. If you did, I do strongly and highly recommend that you go on to explore data visualization in both Matplotlib and other data science libraries. Matplotlib itself is such a diverse and broad library. There is so much to offer within it, and there is unlimited learning that you can do for this program, this library. There's just a multitude of things that you can carry on to do, and I do strongly encourage that you go on to look at these. With that being said, that's all I have for you today. Once again, I appreciate you all for sticking around through this, and I'll see you in another course.